In paper 2, let's get started. There's 8 people in the class. These are the heights in centimeters. Work out the range of the data. Well, the range is the top value, which is 172, take away the bottom value, which is 141. So 172, take away your 141, gives you a range of 31. We're all good there. Write down which of these heights is an outlier. Give a reason for your answer. Well, which one is the outlier? Well, we gotta say it's probably gonna be the 141, because what's the nearest number to 141 is actually 165, which is a full gap of 24 centimeters away. Was 165 up to 172 is only a gap of 7, so it's definitely the 141. 141 centimeters. And what's the reason? If we exclude the 141 from the list, the rest of the data only has a range of 7. You can say rest of the data has a range of 7. Okay, we all good with that? Good job. Okay. Next thing we're going to do is calculate the mean. So the mean is calculating all these values, add them up together and divide by 8. So let's get on that really quickly. So we got our actually I'll just copy and paste it down, be a bit quicker. Okay, 1 second guys, we're going to grab this here. Okay, and reduce this down. Okay, so we're going to use this in my answer. So we're going to get all these together, like so. Going to add them up, so plus, plus. So we're adding all the values together. Okay, and when we add all them together, we're going to get 1,324. Then we got to divide it all by 8. And when you do that, you should get 165.5 centimeters. Okay, all good. Now we've worked out the mean. What's next? Okay, we're on to question 2. Oh, sorry, 1D, which we'll find here. Now we're on to 1D. John says that all the measured heights of the teachers in a school. John also measured all the heights of the teachers in school. He says most of the teachers in school have a height that is greater than 175. Okay, put a tick in the correct box to show the following statements must be true. Right, so what I do is I'd make up my own example. So imagine we had like 5 teachers. I had one on 173, I had one on 174, and then I had 3 of them on 170, sorry, above greater than 175, so 176, 177 and 178. In this case, most of the teachers are bigger than 175. So let's find out. Does the mean height have to be greater than 175? Well, the answer there is no. I could make the bottom 2 teachers very short. So I can make them 141 and 142 respectively, and you'd find out that an average like this wouldn't be an average like this would not be greater than 175. So plus 178 divided by 5. You can see that the average is actually well below the 175 mark. All right, so we put an X here. And you can put this down as the reason, okay, divided by 5, and you divide that by 5. What did we get there? When we divided by 5, we got 162.8, which is not as good. So that's next one. The median height of the teachers is greater than 175. Is the median greater than 175? Let's find out. 141. 142. Yeah, in this case, the median, 141, 142, 141, 142, 176, 177 and 178. Okay, what we could say here is that the median has to be greater than 175. So median would be 176, 176. So yes, the median has to be greater than 175. Now next one, the modal height of teachers is greater than 175. Now that's not true, that's false, because I could set up the following data: 141, 141. See the way two of them are on 141? That means the mode would be 141. So that makes the last one not true. Okay. On the official marking scheme, the median height of the teacher is bigger than 175, so that's what we said. Reason: if the median is bigger than 175 centimeters, the more than 50% teachers must be more than 175. So that's what it's saying here, is that if most of the teachers is above 175, that means that your middle teacher has to be bigger than 175. So that means most teachers will be greater than 175, and that's true. Okay, next thing. The mean due to outliers, so that's where due to 141 and 142, that makes it smaller than 175. Let me see that one again. Yeah, no, see, that doesn't have to be true, because small outliers will cause it to be smaller than 175. That's great. And the mode, as we proved earlier, there could be more than one of the lower outliers with the same value, which means that your mode does not have to be greater than 175. Okay. Question 2. Some of you might remember this from the Christmas exam. Now, this is categorical data. Okay. Now you can't say a bus or a train is better than a car or a walk or a cycle. Everybody has their own opinions. So this makes it categorical nominal. Okay, next thing you got to remember is all of these need to add up to 100. So you get 100 to take away 15.3, 26.2, 8, and 12.1. So 100 to take away 15.3, 62.6, minus 8, minus 12.1. Put all that in your calculator and you're going to get 2.0. Okay, for the next one, get 100. Take away your 1.2, your 71.4, take away your 11.3, take away your 15.4, and what you get is 0.7. Okay, and then finally, when you add all these up here, you should get 100. Okay, because when you add all these numbers together, the calculator together, and you add downwards, you should be able to get 100 when you add them all together. Okay. We're all good, so that's our table complete. So far so good. I'm going to use this table again in a minute, so I'm going to just shrink it down in order of size, move to a new page, and I'm going to have to use the data from this table on all subsequent questions, more than likely. So it's going to make it a lot smaller, easier to read. And now we're going to go for this again. Now, look at the next one. Write down the modal way of traveling for what is the most common way for traveling for both men and women in 2016. Well, the most common way of traveling in 2016 is more than likely by the car. Yeah, and we can see that there. 60% of men drive the car, 71.9% of women drive the car, so the answer there must be car. Complete the table by filling the 3 missing percentages. That's done already. That's what we did here with the filling in all the information. Okay, now we're on to part D. So once again, I'm just going to take my information and bring it with me. Okay, now we're on to D. And Evie says, in 2006, women were more likely to walk or cycle to work than men. Show that Evie is correct using numbers from the table. Okay, let's see what we can do here. Okay guys, so looking for the table. Okay, so let's find out. This is in 2000, and we're talking about 2006. Women are more likely to work or cycle than men. So let's see, walk or cycle. Walk or cycle was 15.4% women and 12.1% men. True, as 15.4% of women compared to 12.1% of men walked or cycled. Okay guys, that's it there. E. Alan says more women must have travelled by to work by car in 2016 than 2006, because 71.9% travelled by car in 2016, but only 71.4% did in 2006. Is Alison correct? Well, it also has to do with the total. That the percentage is definitely higher, but the number of people might not necessarily be higher. So the reason being, Alison is not correct, because 71.9% of a smaller population. So 71.9% of a smaller population could be less or could be smaller than 71.4% of a larger population. Okay. So essentially 71.9% of 1,000 people would be 719 people, while 71.4% of arguments, let's say 10,000 people, is 7,140 people. So you can see that while it's a smaller percentage, it's still more people. Okay, so you got to be careful about that. Okay, F. In total, in 2016, roughly 990,000 men and 808,000 women traveled to work. Using the figures in the table, work out a total percentage of people who traveled to work by bus or train in 2016. Correct to 3 significant figures. Okay, so correct to 3 significant figures. Okay, let's get on that. Okay, so let's have a look at the table. So what do we have on our table here? We have, bring it down. Okay. Now, we're talking about 2016, and we're talking about bus or train. So bus or train is 8.3% of men and 10.5% of women. So what we're going to do is we're going to get 990,000 men multiplied by 8.3%, and that is 82,170 men. And then we're going to get 880,000 women, and we're going to multiply that by 10.5%, which makes 92,400 women. We're going to add both them together to get the total amount of people that travelled by bus or train, which is 174,570. Now, how many people are we talking about in total? Well, we're talking about 990,000 men and 880,000 women. We're going to add the two of them together, so it's going to be 174,570, and we're going to divide that by what happens when we add the two of them together. We get 1,800,070. Okay, now we have to find the percentage if you read the language of the question. It's very much looking for total percentage. So it's the amount of people who travelled by bus or train divided by the total number of people in the population, multiplied by 100, and we're going to get roughly 9.34% when you round it up, and 3 significant figures as shown. Okay, good. Next one. Complete the following table showing an angle in a pie chart for each of the ways men travel to work in 2016. Show your work, give each angle correct to the nearest degree. Okay, so to the nearest degree, what we're going to do is this. Okay, you get your fraction, or so your percentage. Okay, so it's percentage divided by 100. And then you multiply that by 360. Then you get 43.92, okay, which will obviously be 44 when we're drawing it. Then we get 8.3 divided by 100. That's the percentage. Percentage means out of 100. And you multiply that by 360. And you get 29.88. Okay, next one is 60% by car. So 60 divided by 100 multiplied by 360, just be rather a large angle, which is 216 degrees. And then finally, for other, we're going to get 14.2 divided by 100 multiplied by 360. And we're going to get 51.12, like so. And then finally, the not stated will be 5.3 multiplied by 100 multiplied by 360, which will give us 19.08 degrees. Okay, so essentially you're dealing with 44, 30, 216, 51 and 19. Okay. Okay, lads, so your Venn diagram will look something like this. You put all these angles in. Okay. Now what you might want to do is remember when you're making your own Venn diagram, okay, so if you're doing this from scratch, okay, you'd have your compass and then you'd have your protractor. Okay, we'll move these down here. The first thing you do is you select somewhere to be your center. So you always choose your center of circle like so. So you'd have it like this. Then you'd bring in your compass, and then you'd create yourself a circle like so. That'd be that done. Then you bring your protractor to the center of the circle. Okay. Now you adjust it to whatever angle you're looking for. So let's say I'm trying to measure this one here. Now we can see clearly that this is 30 degrees, which is great. And then we doing the walk or the cycle one, so we could reset the 0 mark here now. And then we have to do 44 degrees, so that would bring us to 44 would be there. See the fall marks from 130 to 140, just above the 40, that would make us 44. Then we reset that to this angle here. And we try and get the 19 degrees in here, like so. And finally, the 50 to 51 degrees, we reset back to 0. Go all the way just above 50, and there you go. That would be your Venn diagram done. Okay, so that's the section we just did there. No bother. Okay, the diagram shows the main ways that primary school students travel to school from 1968 to 2016. Okay, so we can see the lines going up. You can see that more and more people are going to work in a car as every year goes by. The number of people who are walking or cycling, which started off at 50% in 1986, is going downwards roughly to about 25% in 2016. We see bus or train had a mild growth in the 90s and now has been reduced in numbers from 1996 down to 2016. Write a paragraph about the following, okay? So we can write a paragraph about the flight and what we did. So we're going to take the answer directly from the marking scheme, okay? And We should mention each of the information from the three lines. So we're using all this information to try find each of the information from three lines. So we got to mention, answer must mention the three ways, lines, and reference to shape, percentages, or comparisons. Okay. So the first one, percentage of students who traveled by car doubles to 50% between 1986 and 2002. So look at 1986, you're here, roughly at 25%. In 2002, you're at 50%, so you can see the cars is doubling, okay? The percentage of students from 2002 to 2016 increases more gradually to 16%. So we see a more gradual increase up to 60% here. Starts off at 50, roughly ends up at 60. Okay, next one. The percentage of students walking or cycling halved to 25% between 1986 and 2002 when it then stabilized. So walking or cycling used to be 50%, half to roughly, 50 something percent. Now we just see it's just below 30, so it's at about 27%. So we're roughly halved. Didn't exactly half, but roughly halved in between 1986 and 2002. And it's stabilized, but it's undergone a gradual decline as the years have gone on. Okay. The percentage of students travel by bus or train was relatively stable at 20% until 1996, and then it decreased gradually to around 10% by 2016. So, trains were stable all the way to 1996, where they were roughly on 20%, and then from 1996 to 2016, over the next 20 years, it roughly went from, let's call it 20% down towards 10%, where it roughly halved. Okay, so that's your that's your paragraph referring to each section. Okay, great. Now, the coordinate diagram shows the following digital clock on the screen, okay? Now, we got to remember is if it's a mirror image, so I'm just going to show you what happens with these ones here. I'm going to just snapshot each one of these individually. The current page, yes I do, thank you very much. So if I reflect this in the axis like so it's roughly the same size as this one, there we go. You can see here that this is reflection, like a mirror image in the y-axis. The 1 goes to the 1, you need a different color, there we go. The 1 goes to the 1, the start of the 5, no, that ain't gonna do us at all, that's not right. Nope. So that one, no, that's not the reflection, so I'm gonna leave that. That's image Q, we'll leave that alone for a minute. Okay, let's try image S. Okay, let's try another one, image S. Trying to figure out which axis each one belongs to. Current page, yes I do, and I want to reduce the size. Now, roughly the same size. Now if I stack the two of them above each other. Alright, this one's more like it. This one here, if we were to reflect it like a mirror in the x-axis, these two will be mirror images of each other. Okay, because you can see the 2 and the 5 are the main ones to look at. The 2 and the 5 give it away, really. They are mirror images of each other, okay? So image S is reflection in the, or axial symmetry in the x-axis. Okay, so one sec, there it is here. We've got this question. Move it out to your side. Okay. So this one here, this is the image S, must be axial symmetry in the x-axis. So this one is S. Okay. Now we're going to try and find image P here. Now image P is unchanged. So image P has to be a translation. Translations is where you move one point, you move them all the same amount of distance. So I'll give an example of what that looks like. Okay, so that'll be an enlargement, not a translation. Okay, so roughly the same. So in this case, you can see that the 1 would move here to here, here to here. They all move the same distance. If I was to move the dots, they'd be here to here and here to here. So you can see everything moves the same distance. This is known as a translation. And in translations, the shape doesn't rotate or change direction, okay? So that means that image P is a translation. So this is image P. Next one, axial symmetry in the y-axis. Well, that's going to be image Q, because the 15 will have to change around. Okay, so the 1 will be closest to the other one. So I reckon we're looking at image Q here. So if I take this image here, send it to the current page, reduce its size, and what we can see here, guys, is that that's definitely going to be image Q. Okay, because see, the 1 is linked to the 1, they're same distance, and the part of the 5. No, that's not it either. Sorry, excuse me, guys. No. Wrong way around. The 5 has to be upside down there. So it's image T. Excuse me, image T. Send to current page. Okay, let's try image T up here. So there you go. You can see it's a perfect reflection in the y-axis. Okay, so this part here of the 5 reflects this part here. You can see this part here at the 5, which is going away from the mirror, it's gone away on the other side. And then you can see this part here, the blue part. Okay, and then finally the purple part here. You can see that it's a mirror image in the y-axis, so that's going to be T. And that finally leaves the last one over, which is Q, which is central symmetry in the last one was Q, which would have been central symmetry. I'll grab it first now. Central symmetry in OO. So I mean by that now. So central symmetry in OO is where you have it goes through the origin to get to the other side. So as an example, this point here travels roughly the same distance from here to here. So when you do when it's a central symmetry, what you'll find is it'll all go through a central point when you link all the points together. So give an example. Next one, if I link this part DO to this part DO here, you will see I'm ever so slightly off in my, and then this part here of the decimal point goes to this one here, and you can see they all converge on a central point, which should be at 0, 0. So just I'm slightly off 0, 0 here, but it should go through the origin. Okay, so that's why that one is the central symmetry. So that's the image Q. Okay, done. Next one, question 4. Diagram below shows the center of the circle as standard soccer pitch. The center is marked at the start game. Gary and the referee stand on 2 points of circle G and R as shown. Okay, so Jorge stands at the point J in the circle such that the angle to the referee is 90 degrees. Using a straight edge, construct the point J on the diagram above. Label the point J. Okay, so let's figure out what we need to do here. So what we can do here is draw Gary, get a line, get a straight edge and a line, and then just draw Gary, a straight line from Gary to the other side, like so. Okay, and this guy here must be Jorge. which would construct J. Now, if we were to do the rest of the diagram, linking the referee back up to Gary, we could measure this as a right angle. Okay, so this is 90 degrees. Okay, so label the point J done. State a theorem or corollary that justifies your construction in part A. So this state angle is each angle in a semicircle is a right angle. So each angle in a semicircle is a right angle. So that's your semicircle is your half a circle, with this being the diameter, and that's 90 degrees. Or the angle at the center of the circle is twice the angle at any point on the circle standing on the same arc. So if this is 180 degrees, and your center of your circle is sitting on an angle of 180 with the 2 points, that means to a third point on the same circle, standing on the arc J to G, would be 90 degrees. So take your pick on the way you'd like to explain that. Now, nextly, question 5. Label each of the following points on a label each of the following points on the following graph. Okay, so we can see the shop is minus 3, 1. Minus 3 across 1 up. Home is 4, 2. 4 across 2 up. And the school is 4 to 5. 4 across 5 up. The library is at the midpoint between home and the shop, right down the corners of the library. Well, you're going to use the midpoint formula, which is x1 plus x2 over 2, and then y1 plus y2 over 2. Okay, in this case, we are using the home and the shop, so that's x1, y1, x2, y2. So add them, so it's minus 3 plus 4 divided by 2. And the other part is 1 plus 2 divided by 2. This means your shop is going to be a half and 3 over 2. Okay. So 1.5 and a half and 1.5. So a half is here, 1.5 is roughly there. So that's my library. Okay, done. Next thing. Next question is, work out the distance from home to the shop on the diagram. So home and shop. So these 2 points here I'm going to have to use once again. So just take all 3 points because I'll need them on the next page. So into new page. Use these points here for my remaining questions. Okay, so my distance formula D is x2 minus x1 plus y2 minus y1 squared. Okay, and what we're going to get here, we label these correctly. We call u x, we already have x2 and y1 sorted there, so it's going to be 4 minus 3 squared. And then it's going to be plus 2 minus 1 squared. Throw all that into the calculator, you should get root 50 or 7.07 centimeters. Okay, the distance on the diagram from the shop is roughly 8.1 centimeters. Using a diagram of scale is 1 is to 25,000. This means 1 centimeter on the map will be 2,500 centimeters in real life. So what we're going to do is we're going to multiply the 8.1 by, so we're going to multiply 8.1 centimeters by 2,500. And what we get is 20,250 centimeters. We then divide this by 100 to turn into meters. So it's 202.5 meters in real life. Okay, brilliant. Now E. Tina walks from the shops to the school. Explain why the distance she walks is probably more than the actual distance in part D. Well, you have to take into consideration there could be an altitude change. Okay, so there could be, well, there's 2 reasons. So you could say if you had a shop on the map, the shop could be here and the school could be here. And you could think that you could go straight across like so. But there might be roads. So certain roads means that you could end up going this way if you take the roads to school. So there's no guarantee there's a road going straight from the shop to the school. And the other thing is it's also assuming perfectly flat ground. So there could be like a slight incline going up from the shop to the school. So this could mean if by Pythagoras' theorem, the hypotenuse would be a longer distance than the distance calculated in part D. You could also try that out as well. Okay. The answer in D is the shortest distance between the 2 points. It is unlikely that the path she takes goes in a straight line between the 2 points due to buildings and roads and other reasons. Okay, so that's a good reason as any. Now, the coordinate diagram below shows the line L drawn from the school to the shop. The angle A is marked here. Work out the slope of the line, give your answer as a fraction. Well, two ways of doing it. You could do rise over a run using your diagram here. It has a rise of 4, so it goes 4 up and 1, 2, 3, 6 across. This would indicate a slope of rise over run, which is 4 over 6, which is 2 over 3. You could also use the slope formula if you wanted. Oh wait, I'm losing it here. Oh, sorry, that's 7. 4 over 7, my bad. 4 over 7, 7 across, 4 up. 1, 2, 3, 4, 5, 6, 7. You could also use the slope formula using the points 5, 4 as x2, y2, and you could use the shop as x1, y1, and you could figure it out that way as well. But I like to rise over run since the formula's already done for you. Okay, next part. Find the equation of the line L. Give your answer in the following reaction. Okay, so we have the slope, which is great. So we're going to use the formula y minus y1 into n into x minus x1. All I have to do is put in the slope as 4 over 7, and I have to pick any point that's on that line. So I have a choice. I can choose minus 3, 1, or I can choose, sorry, not 5, 4. That's 4, 5. I choose 4, 5, so I'll probably choose 4, 5 to be honest. Both of them are positive, so it makes things easy. So I'm going to choose the point 4, 5. So it's going to be x minus 4 and y minus 5. Going to cross multiply the 7 to get 7y minus 35. Then I'm going to get 4x minus 16. I'll move everything over to one side, so I'm going to get minus 4x plus 7y. I'm going to get minus 35 plus 16, which is minus 19, equal to 0. Multiply both sides by negative, and I can get 4x minus 7y plus 19 equals 0. Both answers at the end are acceptable because they have to be all integers, which means they can be positive or negative numbers. Okay, it appears there's a part H as well, is there? Use trigonometry and the slope of L to work out the size of the angle A. Well, if it's 4 over 7, as we can see there, and it's a right angle triangle, so this would be opposite is 4 and the adjacent is 7. So we can use some SOHCAHTOA. Sine equals opposite over hypotenuse, cos equals adjacent over hypotenuse, and tan equals opposite over adjacent, which is what I have. So we can say tan of my angle. What angle do we call it? We call it angle A. Tan A equals 4 over 7. Now we have to find out what is the angle, so we use the tan inverse button on our calculator. Tan inverse 4 over 7. Please make sure your angle has this D at the top, otherwise it won't work. Shift tan inverse 4 divided by 7. And lo and behold, you get an angle of 29.74, so 29.7 degrees. Okay, that's H done. Next one. The diagram is made up of 2 equilateral triangles and 2 parallelograms. Write the correct letter in the spaces below to show what type of angle each one is. Okay, so an acute angle would be smaller than 90 degrees, so that's going to be K. A reflex angle is bigger than 180 degrees, so that's going to be n. An obtuse angle is in between 90 and 180, so that would make that m. Okay, next question. Work out the size of the angles K, M, and N. Remember that the two triangles are equilateral. Okay, so I'm going to need to bring this diagram onto my next page. And keep remembering that the triangles present are definitely equilateral. Okay, so let's figure out how to do this. Now, okay, so what we can get here is m is 100. If k is 60, m is 120. That makes this one here 60. Now, using opposite angles, that's 120. 120. Sum of two interior angles, because they're both parallel, so they had to add up to 180. So that makes that one 60, and that one 60. So k, trying to figure out which one's which now. K is 60, m is 120. K is 60, m is 120, and n is going to be 360. Take away 120. See the two 60s here? So that's going to be 240. Okay. Two equilateral triangles are not the same size as each other. Siobhan says the two triangles are similar, but they are not congruent. Give a reason why the two triangles are similar. Okay. Now, first of all, congruent triangles means that they have to be the same in every way. They have to be the same length and the same size. So we can definitely know they are not congruent, because to be congruent, you have to be identical, which means your lengths have to be equal, which they are not. However, to be similar, you just have to have equal angles. So because we know that in an equilateral triangle, all the angles are the same, therefore we can say that both triangles are similar. According to the marking scheme, that's what I would write down word for word, but congruent triangles are the same size, and these two are not. That's great. Both triangles are equilateral, and similar triangles have equal angles. Exactly what I said. Cool. Good to go. So we did part 1 and part 2 there. Okay, we're going to try and construct a diagram. Show clearly any construction lines that were used. Okay, we're going to give this a go. Okay, so the first thing I'm going to do is, if I know that the smaller triangle is 4 and the bigger triangle is, if I know the smaller triangles of length 4, I'm just going to make my parameters just a little bit smaller, right? So if this is, so I'm going to do this dot from here to here first. So this purple dot to this blue dot. This purple to blue dot will be combination of 8 plus 4, which would be 12, right? So I'm going to do a 12 centimeter line to begin with. And hopefully you get some nice lines here. So there's my 12 centimeter dot to begin with. I'm going to get a compass out next, okay? This compass here. And if I make every length the same, I can draw myself an equilateral triangle really quickly, okay? So 6 centimeters here, like so. So what I'm going to do here is going to draw, there's my first little marker for 6. Then I'm going to come up here, draw it like a little arc. Then I'm going to reverse it around. Go back up to 6, like so. And then, there we go. See where that mark is made? That is going to be my equilateral triangle. All the angles will be 60 degrees, which is perfect. And then I've got my first 60-degree angle, like so. Now, next thing I'm going to do is I can continue this line down here, because if that's 4 and that's 8, then I have another one of length 12 as well. So I can go from here to here. Up, and do the last two things there. 1, 2. Okay. Can't mess with the size. So I need this to be 12 centimeters as well. So I'm just going to match that up to the 12. like so. So once again, this is going to be 12 centimeters all the way down. So grab this and make it 12 centimeters all the way down. Okay, that's pretty handy. Oh, so I make it 6 centimeters or 4 centimeters? Oh, my bad, lads. So I'm going to go back to the start here. I made it 6 centimeters, not 4 centimeters. Foolish me. So we'll try this again. My fault. I meant to make it 4 centimeters, not 6 centimeters. So this is 4 centimeter mark here. Okay. And then what we're going to do is we're going to construct our equilateral triangle, like so. Spin this around. Like so, and there's our 2 points there. That makes this an equilateral triangle. Okay, awesome. Now, as I stated earlier, is I have to make sure that the other part is still 12. So I line it up 12 up here. So I gotta make this 12 centimeters because it's 8 plus 4. Yeah, that's as good as you're gonna get it. Okay, and that's gonna be 12 centimeters as well. Then if I join the two of these together, that will be, didn't have to construct that part. That'll be 12 centimeters there. And then to do the rest of the diagram, I just need to finish off the parallelogram now. So this is going to be 4 centimeters straight across, like so. So I'm going to go down here. I'm going to do 4 centimeters straight across from this point here to this point here. Then linking this 4 centimeters up to this 4 centimeters there. Okay, and now finally gotta do the last part, which is gonna be carrying the angle over. Now that was easy because it was straight down across. Now here comes the hard part. This is the more difficult one. I need 2 straight edges, like so. And what you do is you tend to line up one of them with the other one. So I'm gonna have to line this edge up perfectly. Okay, see this here? Then line this edge up so you can sort of slide it across. Now see that there has to be no gap in between the two of them, so I'm just going to see what I can do here. Now if you imagine that you're pushing down, need it to be lower even. I'll explain why. You're imagining, see the way it's in line here, see the way that's in line, you're imagining you're pushing down with the, you're pushing the set square on top of the ruler, and then you're doing a line like this. You have to go a bit higher because you don't know how long to go. Now what we can do next is we can get our compass, which is hopefully still measuring my 4 centimeters, which it is. Then when it measures the 4 centimeters, what I can simply do next is put the 4 centimeters up here like so. See where that hits? That means I can draw it here to here, and there is my diagram. Done to perfection. Okay, all very happy, all good. Now, I think we'll take a pause there